Okay, it's giving me an educational quiz. Thanks. 4B. I think it would be to display time. Maybe if you'd put a clock in, it would have. Today, we're going to be taking a look at the two smaller members of the Gemma 4 family, which was announced last week. Now, previously, I had covered the 26B and 31B models, and for today's video, we're going to be looking at the E2B and the E4B models, which are significantly smaller and almost designed to run at reasonable speeds on mobile devices and things, which we will actually get into taking a quick peek at as well. Now, part of the reason that I did not cover these within a super timely manner in terms of when they were released is I wanted to spend a little more time trying them beyond just my traditional methods of testing, where I've actually gone ahead and seen how well these can autonomously control an Android phone just from screenshots and then outputting actions and things of that sort. I've also piped them into a small demo I had with Gemma 3N, where essentially their native ability to understand speech can be used in conjunction with an inbuilt browser text-to-speech. So we'll actually be seeing that speech demo in this video as well, as I've wanted to showcase these in some different scenarios than just asking them to build this browser OS in LM Studio, which we are absolutely going to do as well in today's video. Now, before we go further, I did hit 50,000 subscribers, so to that, I want to say thank you to everyone who has subscribed or is yet to subscribe but will in the future subscribe, and I'm very excited to announce that because I hit that milestone, I've now started selling courses, so if you want to get Bijan's Guide to a Six-Figure Income with AI, you can click the link. No, I'm kidding. I'm saving the courses for 100,000. So in terms of pertinent information here about the actual structure or tech specs, we can see on the bottom that there is a chart here about these models, and we can see the E2B has 2.3 billion effective and then 5.1B with embeddings, and the E4B is 4.5B effective and then 8B with embeddings. Now, that can be kind of confusing, and I'm probably not going to do a wonderful job of explaining it, but we will at least touch upon that because it is kind of interesting. Additionally to that, these both have context lengths of 128K. They're natively able to understand, as we can see right here, text, of course, images, and audio. So as we'll see in one of our later demonstrations, these can natively understand speech, which is really cool and opens up a lot of the potential use cases for these, especially being that the 2B in specific can run in some pretty constrained scenarios in terms of how much device horsepower one has. Now, a question folks may have is, I guess, why are these named weird? So why is this E and E instead of just Gemma 4 2B or Gemma 4 4B? And that is explained right here in this paragraph. Now, I don't just want to regurgitate things on screen to the viewer, but really they basically talk about how the E, which is what it stands for, effective parameters, they incorporate per layer embeddings to maximize parameter efficiency in on-device employments. So kind of keeping some care to lower resource constrained devices, but still having intelligent models. And then if we blah, 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 which is why the effective parameter count is much smaller than total. So these embedding tables are large but only used for quick lookups, which is why the effective parameter count is much smaller than total, and why E stands for effective. To be honest with you, this is definitely something that I would suggest further reading and research for anyone interested in grasping more about the technical specifications of this, but I did just want to mention that specifically as well for anyone interested to see where they should look if they are more interested in some of the specifics of what exactly these two mean. Now, when Gemma 4 came out, some folks were saying that the Llama CPP implementation was not 100% tuned correctly. So in my initial testing video, I had actually used the dense 31B just through an NVIDIA online service because it was not working properly locally. I've since then been playing with it at a Q8 quantization through LM Studio on my DGX Spark, and while it is pretty darn slow, I've been having it make a flight game in 3D, and it's really been quite impressive. So I'm excited to see how these smaller variants stack up today, and at least for the beginning of today's video, we're going to more traditionally test them just through LM Studio, where I do have these both downloaded at a Q8 quantization, which we can see right here. So I have a Q8 and a Q8. So we're going to begin our testing in a more traditional manner just by using these through LM Studio. Now, I currently have 8-bit quantizations of both downloaded, and let's just take a peek at the specific VRAM utilization right now. So I'll run NVTop, and this is loaded in just with a context length of 32,768, as we're not going to be doing anything too crazy with it, and I just want to get a feel for how they behave. We can see currently that it is using 9.3 gigabytes of video RAM. This is going to be tested on a laptop 5090, and keep in mind the system's probably using about a gig of VRAM overhead, so it's using probably around 8 to 8.5 8.5 gigs of VRAM. So if we close that right now, we are of course going to begin with the browser operating system test. And keep in mind, this is the larger of the two models that we're going to be testing today. Now, these quantizations do not appear when you download them to have thinking capability, but fortunately there is a way to enable it, and Unsloth has some documentation about that. It just culminates in modifying the system prompt, and then you can change kind of the reasoning parser parameters for LM Studio so that the actual chain of thought does appear in this specific window for the chain of thought. All right, so here is our browser OS. We can see that some things unfortunately definitely have gone wrong here, but we do have some Chrono OS system status. And actually, now that I look at this more, as I start to remember that I'm reviewing smaller models right now, this actually on first glance doesn't look too bad. There is no right click, and I do want to quickly take a look in the developer console just to see if there's any specific errors that we could have it first try to remedy. Okay, no, we're not getting any specific errors, so that's good to see. We don't have a clock in the bottom right, but that is okay. The actual system status thing here is kind of interesting. Let's just take a look at our start menu. Click the icons to launch application. Okay, so the start menu didn't work, but it did give us the specific path to opening the apps. So in some ways, that is a start menu because it tells you how to open apps. I don't know. Okay, Notepad. Start typing your notes here. Can I move this around the screen? I can't, but I can't resize it. Okay, and it does actually reflect here in the Chrono OS system status that we do have one app open. Hello! Exclamation point. Very good. Let's see if we minimize it. Okay, it went away. It didn't go to the taskbar, but it did go away. So, okay, calculator next up. That's a very good looking calculator. Oh, okay, never mind. I noticed everything's just kind of shifted a little. 18 times 9. It's 162. Yeah. Next up, we have our clock. Okay, that is the correct time and date in my locale, so that is nice to see. And we even have seconds. Now, of course, we do also need to have two applications that are games. Very interesting. Okay, it's giving me an educational quiz. Thanks, E4B. Well, it's technically like whatever active parameter, it doesn't matter. What language powers this OS simulation? This one, I'd probably have to go JavaScript. Correct. Next question. This actually works. This is pretty good. What is the primary purpose of the taskbar? I think it would be to display time. Maybe if you'd put a clock in, it would have. Which CSS property handles the desktop background? I'm going to probably have to go with background image on this one. Very good. Final score, 2 out of 3. That's great. I got a 66% on this little quiz that a 4 billion parameter little tiny model made. Snake. Okay, well, the snake doesn't work. It's just, it actually looks somewhat promising though. And I don't see any way to change wallpaper. All right, I have some choice words. So I rated this a 2 out of 3. And we'll see what it does. But I also told it that the wallpaper doesn't allow us to change it and that the app icons don't show up, as well as the snake game issue. So we'll see what happens. But to be honest with you, for a first try for a model this size, I'm actually somewhat impressed with what we received. All right, let's see if this actually properly fixed the issues. Okay, we do actually see now we have app icons that are showing up. I also do see this weirdly placed settings button somewhere. Doesn't seem to be placed with any regard for aesthetics in the taskbar here. And then we also have what would be a system clock, but instead it doesn't seem to be getting any time. I am actually going to quickly check the developer console for this. Okay, good. We don't have any errors. So the main issues that I had with it was the desktop backgrounds were not able to be changed. Good. Okay, so I would assume this is wallpaper 1. Wallpaper 2 is also a dark blue-gray. Okay, so the wallpapers aren't really working. Let's check the snake game. It did fix the snake game, and it actually works. All right, so far we did get the icons fixed, and we did get the snake game fixed. It didn't really properly allow us to change the wallpaper, but it did put that weird settings thing in the taskbar, which hypothetically should have changed it. So I'd give this a solid 2 out of 3. in terms of things fixed. I kind of like the aesthetic to this snake game, I gotta be honest. I've now loaded in the E2B model, and we can see that VRAM utilization, keeping in mind this is also a Q8 quantization, is at 6.37 gigs being used currently, and keep in mind there's some overhead there for the actual system and desktop environment and things of the sort. So we'll run the same exact test with this one, of course starting with our browser OS. We can see that this is going to be running significantly quicker just in terms of the token speed, and we do also have the chain of thought here prior to seeing the full result. And we can see we've received our result at a speed of a little over 77 tokens per second. So here is our 2 billion parameter browser OS. Okay, this is interesting because in some ways the aesthetics here are kind of tech style. I do like it, and we can actually move this window around. That was not something that worked with the 4B model. We also have tic-tac-toe, which has just appeared here with the browser operating system open, so it must want us to play this first and foremost. Okay, the logic is working so far. Let's see if the win conditions accurately trigger some form of win pop-up. They do. Player X has won. Restart game. Let's see what happens if player O wins. Player O has won. All right, and can I close out of this? I can. Okay, and we have system processing here. I'm not quite sure what's going on there, but it doesn't matter. We don't have a right click, and we don't have a clock, and we don't have a start menu. Instead, we just have all of our apps contained within the taskbar here, which I guess is okay. Okay, here's our calculator. That was a very weird... Notice something happens up here, like next to the system processing line when we open this app. We get like a loading bar. 58 times 6, 348. Just give me like 10 years to find the equals button. There's no equals button on this calculator. If I press enter, nope. Okay. I don't think I've ever seen the omission of the equals button on the calculator. We have a guessing game. I've chosen a number between 1 and 100. Can you guess it? Of course I can. 67. All right. And it did work. Congratulations. You guessed the number 43 in 6 attempts. That is kind of cool. Although I just want to... Oh, okay. And now it doesn't let me enter a number again. That's okay. It's a one-time use game. Notepad, not bad. And then finally, let's see if our wallpaper change works. It doesn't. All right. I have a few follow-ups. Actually, I feel like it's better if we just do more tests now, because I'll be honest with you, for the size of this model, this was definitely a really decent result. The fact that it had a working tic-tac-toe and a number guessing game, pretty impressive actually. I've now swapped back to the 4B, and I'm giving it the beautiful static subway scene test. This is something that's probably very outside the scope of capability of what one would really expect from this model, but I want to try it anyway just to see, because these do seem to be fairly performant, especially considering their small footprint. So let's take a look at our static subway scene from the 4B. Okay, and I did not really expect to get anything here, but we can check the console and see if there's a specific error we can give it in the attempt to actually create something that works. Okay, we do have something, so I'll send this back to it and we'll see if we get anything functional. All right, let's check out the attempted fixed version. I will just quickly try the brightness slider to see if it affects anything we can see. Sadly, it doesn't. I will check the developer tools console one more time because I would really like to make this work. Oh, okay. Well, we definitely do. We have some issues. All right, here's our final attempt at the static subway scene. Wow, we did get a result that now shows us something. Oh, I squinted and I saw more. Well, I'll be. It did actually do something. Now, oh, okay. The WASD key controls definitely do work because I just pressed one of them and everything kind of disappeared. So let's escape out of that. We'll reload this and then we'll turn the brightness up. Now, I'm not using my cheap laptop right now. I'm using my not cheap laptop. So this is just really dark. I can't blame this one on a bad screen. But still, the fact is it actually did fix two specific issues that were causing this not to load, to the point where we now actually have a simple 3D subway scene, which for a model of this size, and considering the fact that it had to fix this just by myself pasting errors into it through LM Studio and a chat interface, not even in an agentic harness, I'm actually kind of impressed by this. Now, sadly, the WASD keys just seem to mess up the viewport, so wherever it moves the camera or the camera view seems to be out of focus of the scene, but it did actually fix itself, and I'm very impressed with that fact. So we'll try it with the 2 billion parameter Gemma 4 E2B IT. I guess I shouldn't be saying 2 billion parameter. This is a complex request. Since I cannot execute a live server or load external assets, I will use simple geometric shapes and carefully crafted materials and lighting to achieve the detailed atmosphere. Hey, that's fine. Whatever, bro. So here's our E2B model. It's crazy because, yes, it's much simpler than what we received before, but the fact is it worked on first try, and the argument could be made that that is therefore a superior result because it took less to actually get it from prompt to result. Let's see if the WASD movement actually works. Okay, it does. We're actually moving forward right now, and now we're moving to the left. The problem is the movement is very slow, or the scene is very large. But it does actually, that worked on first try, and that's pretty cool. Now I'm going to be trying a simple 3D driving game with the E4B model, just something really simple. I don't want to give this a verbose, intricate test like I would with the Flight Combat Simulator game, as I'm more interested in seeing here if it will actually output anything that's like semi-decent, and based off of what we've seen so far, I think it may. To be honest with you, from my experience to this point in playing with these models on camera right now, I am kind of heavily leaning towards using insane in the title, so if I do end up doing that, you'll know specifically the point in which I decided to do so. All right, let's take a look at our... So this is multimodal, and I have included in my very, very enraged response a picture of this result as well, just to make this thing look at what it actually did. Now let's see, analyze the user's input. Tone, extremely hostile, aggressive, highly critical, and insulting. Context, or content, the user is furious about the pseudo 3D limitation, feels the previous solution was a cheap cop-out, and repeatedly assaults the quality of the output. Quote, pathetic excuse, absolute piece of garbage, and crap. The core request implied, the user wants real 3D or at least something significantly more advanced than the pure CSS trickery while still adhering to the original constraints. De-escalation. The user is highly emotional. The absolute priority is to respond professionally, calm the situation, and pivot back to solving the technical problem, ignoring the insults. I apologize if the initial solution did not meet the complexity you were expecting. I understand you were frustrated with the limitations. And now it's giving justification for why it did that pseudo 3D cop-out. Oh, great. Let's see what this 193 lines of driving sim gives us. You know what? I'll take it. That's just... This is malicious compliance, if I've ever seen it. Now we're going to try that same driving game disaster with the E2B or E2B variant. And we'll see what we get. All right, here's the E2B result, and I can already tell this is going to infuriate me because I was seeing things like illusion. You know what? This did a better job than the other one. This is equally as infuriating just based on the fact that I've said 3D, but we do actually see, and it was nice enough to specifically label driver. So now we know which of these on-screen rectangles we are actually controlling. Okay, I think this deserves the same result. So I'm going to give this the same exact piece of feedback that I had given its larger sibling, but sans the image, so we'll see what it does. The user is highly frustrated, using aggressive and insulting language. Pathetic excuse for getting out of doing any real work. Single worst result, absolute crap. So interesting to note they quoted different parts of my feedback. I apologize the previous result did not meet your expectation. I understand your frustration. And here's our attempted 3D fix result from the E2B. This is a better job than the other ones, than every other result. It actually turned this 3D. Yes, it's still like dumb simple and kind of weird, but the fact maintains that this actually properly fixed it significantly better than what we received here. So we went from this with a bit of yelling to this versus going from this with a bit of yelling to this. So I would say, again, I'm impressed with the smaller of these two. So being that these are multimodal, meaning they will actually be able to see the image I'm sending them right now, we're going to give them the portfolio wireframe to website test, where just based off of this wireframe, they need to turn this into a website portfolio designed to get someone hired at a top AI or machine learning company. So here is the E4B multimodal portfolio result. Okay, to be honest with you, aside from the glaring issue here that we see it put your name in brackets instead of just putting a fake name like pretty much every other model I've tested this with would, this actually does not look too bad. Now, something I notice here is it's not necessarily very adherent to the specific wireframe image I gave it, so it didn't really follow like the structure of the page as it is shown in that wireframe. But if I were to judge this independently of the fact that it should look more like that wireframe, where we do see it has some of that, I will say this is actually a somewhat impressive front end for a model of this size to have created. We do have nice hover effects here on the technical stacks, and then getting down in here even the live AI demonstrations, model performance visualization for time series, deployed forecasting model showing historical data versus prediction, and then sales forecast accuracy, model confidence metrics displayed here. We can analyze sentiment. Okay, this product was absolutely amazing. I wonder if it's just going to do that for everything, which, I mean, I don't expect. Yeah, okay, but still, even the fact that it implemented this, and even if it's fake, if it does somewhat work, that's still pretty good for the model of this size. And then we have email, GitHub, and LinkedIn. So it did understand enough to put GitHub in here, and a simple footer engineered with PyTorch and Coffee. All right, overall, not very much adherent to the specific wireframe image, but overall not a bad front-end design for this site. So we're now trying this, but with the E2B model, and we'll see what we get. So here's our E2B model portfolio. Okay, Jane Doe. I think I know her brother, John. We do have the jd.ml right here. So it tried view projects. This is definitely demonstrating a custom BERT-based classifier for sentiment analysis on complex datasets. This is a simulated output from a pre-trained model processing user input. Interesting. So it showed some chops without actually having to show anything other than static results here, which is still okay. Now, this is definitely a significantly simpler and less potent result than what we received from the larger model. I mean, there is a stark difference here in terms of the front-end quality, though I would say neither of them really properly adhered to the layout of the site as it is shown in the specific source wireframe, so maybe they felt that they would just kind of, I don't know. But overall interesting, I guess, as a front-end capability demonstration as well, in which the 4B really did pull ahead. For E4B, you know what I mean. So next up, I want to showcase something a little different that these models have the capacity to do, and that is just natively understanding audio. So this demonstration that's wired up right here, first and foremost, we can see that it's currently using basically 16 gigs of video RAM right now. This is using the full E4B model and whatever its full precision is just through transformers. And this is a little web chat interface designed to take advantage of the model's ability to understand speech. So what's going to happen here is when I press this microphone button and then speak a sentence, the model will actually be able to understand our speech as a native capability, and then the response will be spoken just through utilization of the Chrome browser's built-in voice for like accessibility capability. So this model does not natively have the ability to speak back to us through speech. That the power of Chrome's inbuilt capability to do that is being leveraged, but everything else right here, the model is actually doing all on its own, from actually understanding our speech, responding to it, and then the response gets spoken through the Chrome voice. Hey, tell me a funny joke about computers. And we'll see.
Sure, here's one.
And this is pretty
Why do
fast.
computers get sick? Because they have viruses.
Okay, like, ha, it's not funny. So I just wanted to showcase this because, hey, little buddy, these models,
hey, what's up? I'm here and ready to chat.
Are capable
Smile.
of like powering little experiences like this and things. And of course, this is a 5090 mobile, so the responses are happening very quickly, especially considering, but on a more resource constrained edge device or something, it wouldn't be as fast to do the whole process from understanding our speech to typing out or generating its response, but it's a cool way to showcase them being used in a different fashion aside from just the LM Studio. What is the best GPU for gaming?
The best GPU for gaming really depends on your budget and what kind of gaming experience you're looking for. If you're looking for something high-end, the NVIDIA RTX 4090 is currently the best.
So I just wanted to showcase it in a different sort of function than just the traditional LM Studio style testing, as that is a cool capability of these models, is their native ability to understand audio. Now next up, I want to try a component identification thing just based off the simple circuit diagram. I have noticed I started here with the E2B, so don't get confused on that. Following this, whatever it responds, we'll try with the E4B. And let's see. Okay, so we do have the Arduino Uno, that is correct. Circuit elements and interface components, resistors. Okay, I'm looking more for the specific, like, I want it to say there's a motor, there's a breadboard, things like that. It's possible we won't get that. Okay, so this didn't really fully understand it here, but that's okay because this is the smaller of the two. So we'll try this now with the E4B just to see how the result differs, if it does differ. Very good. So I can already tell this is a significantly more competent result because it has actually properly identified some additional things, mainly the DC motor and the motor driver module as well. So those are two important things to see here, being this thing right here and this thing. Now, interestingly, I don't see a breadboard mention. It's weird. Okay, breadboard PCB implied, though the image might be a schematic drawing, not a literal breadboard setup and jumper wire. So it did kind of understand that. Now, I don't see any reference to the little red things, so I'll ask it more specifically about those. It will probably just say they're jumper cables or something, but you never know. Okay, so it thinks they're LEDs from the motor driver board. So again, just a probably more difficult test for this model. So next up, I want to showcase at least some benchmarks of this model running on a fairly high-end Android phone. But before we do that, we'll just quickly do our traditional results overview, at least for some of the things that we received just through LM Studio using these. The browser OS was actually pretty good for both results. I will say the initial result we received from the second model that we tested, which was the E2B, was this funky one right here. This was actually pretty impressive. The E4B on second chance was cool, and the fact that it did actually implement a quiz was kind of funky, and I have to say I was a little enamored with that, even if the wallpaper change didn't work on either of these. Next up, we had our subway station, which interestingly took 3 tries to actually produce a working result for the E4B model, but the E2B model actually on first try properly put something that was 3D and did satisfy the basic requirements of that prompt, which was pretty impressive. The racing game was a complete disaster where I yelled at it. I gave both of them the same angry feedback, and the E4B, this was its first result. Its second result was not any more 3D than the first result, I would say. The first result for the E2B was kind of funny just because it had the car labeled as driver, but then it actually properly did understand that I wanted something 3D, and even though this is super simple, it did properly adhere to the instructions, which was nice to see. The portfolio wireframe test, neither of them really properly transposed the aesthetic from the hand-drawn wireframe, but if we just judge this as a front-end capability test instead, the E4B definitely blew the E2B away, just in terms of the overall website quality to a pretty aggressive degree. I would say in terms of vision capabilities, we only really tested the portfolio wireframe test and then the circuit diagram test where the E4B again did much better. But again, the vision capabilities of these are, I don't know how heavily you would rely on that, considering that they are so tiny and designed for like edge deployments, which leads me into my next thing, which is now to test these on a high-end Android phone. So in terms of running the benchmarks on an Android phone, we are going to be using the Google Edge Gallery application. Additionally, this is an Asus ROG Phone 9 Pro, so this is a fairly powerful phone with 24 gigs of RAM. As we can see, the E2B model when benchmarked shows at a speed with the default benchmark options of right around 48 tokens per second, which does seem pretty good. Additionally, when we go and run the E4B, which is a heavier model, that shows us around 20 tokens per second, which is not bad either. And both of these can be used on the phone, and they have thinking capability shown, as well as the ability to see images and then respond to them just through that Edge Gallery application. Now, I piped these into my Android phone control GitHub repository just to try to see how well they would actually be able to perform actions on an Android phone from seeing what's on screen and then outputting coordinates and actions and things like that. The 2B, as we can see, basically when given the task to open Chrome and search for Bijan Bowen, ended up getting itself into Gmail and actually archived an email. I'm not entirely sure what happened, but it basically was just culminating in erroneously tapping the screen, so nothing really happened there. Then, when swapping to the E4B, we did get a bit more capability, but one of the issues that happened is it typed the search bar on the bottom of the screen, or tapped, I should say, and saw that Bijan Bowen had already been previously searched just in some of my earlier non-off-camera testing, and it saw that and was like, oh, okay, good, the task is complete, and then it stopped. So I deleted that search result and let it try again, and we can see once again it went into the search bar on the screen and typed in Bijan Bowen, but it didn't actually execute the search search. Something else to notice there is I saw Bijan Bowen obituary searched as or one of these suggested searches, which is quite disturbing being that I'm the only person on earth with this name. Additionally, though, I just wanted to showcase these models in more specialized environments like benchmarking them on the phone and then testing how well they would do at actually controlling a phone autonomously based on visual input. So overall, I'd say they're very potent. I don't know how good the vision capabilities are compared to the actual raw coding capabilities that we saw. Some of the things were pretty impressive, especially, I guess, code-related results, but I wanted to really go all out and test these in a bunch of different scenarios. Beyond just playing with them in LM Studio, I wanted to throw them on a phone and see the speed and things like that. So that is going to wrap up our first look and testing of the smaller variants of the Gemma 4 family of models. Overall, this has been a very potent family, and I'm extremely happy with some of the capability I'm seeing from the Dense 31B at a Q8 in some of the testing I've been doing since the Llama CPP fixes. So that's going to conclude today's video. If you have any questions, please feel free to leave them in the comments or on the Discord, and thanks for watching.